Can all of you see the board, Lamar? Okay. So up to this point, did you understand? Okay. Then we have two more terms to learn. That is the angle between the incident ray and the normal. I label it as simple I. We call this angle of incidence. And the angle between the reflected ray and the normal, we denote it with simple r, which means angle of reflection. Angle of incidence and angle of reflection. So these are the terms with relevant to reflection of a plane mirror. Any questions? Okay, then let's start writing. Okay, make a draw karega na, then I will write a point at the bottom. Start writing, Nama, yeah? Samaya, here one point that I wrote is that මෙතන මේ විදියට reflection පෙද්ද here angle of incidence and angle of reflection are equal. We will talk about this more in a bit, but just write it here as well. Quickly write this note, Lamai. Rashmika, can you click on this link and check? Lamai, 2 more minutes. Quickly finish writing. Lamai, just asking because it says my connection is not very stable. Can you all hear me? මම ඇහෙනවා නම් thumbs up එකක් දෙන්නකෝ එක්කෙනෙක් හරි කමක් නැහැ while you're writing. Okay, okay.
Can clear it issue.
Okay, great. 1 more minute, finish writing. Who has finished already? Give me a thumbs up. Others? Okay, then let's move on. Then, Lama, in grade 9, there was also something we learned. Do you remember we learned something called laws of reflection? Under that, we learned 2 laws of reflection.
Yes, teacher.
Yes. So, Edika, let's revise it a bit. There's nothing much. Put a subtopic. Laws of reflection. First law. ඒ කියන්නේ එකම plane එකේ incident රේඛායි reflected රේඛායි normal එකයි ඔක්කොම එකම plane එකේ. That means you can draw on a piece of paper 3D නෙවෙයි. And the second law is what I told you earlier, angle of incidence is equal to angle of reflection. ඒක ටක් ගාලා ලියාගමු ළමයි. Yes, Risindi, can you click on this link again? සමහරට ආයෙ click කරොත් නෑ නෑ. එහෙනම් wait 1 second. Check if you can see now. what I last wrote is second law. Angle of incidence is equal to angle of reflection. Can you see it? Hmm? So on the board, what I have written last is second law equals angle of incidence is equal to angle of reflection. Can you see that part? No. Even now? Still no? Okay. Then click this link again. Let me notice Cindy. Cindy, then can you log out of Zoom and try logging in again? There may be a problem. Okay. Until you come, I won't start, so quickly join. Okay, Lama. Now, right, given below is how images are formed from a plane mirror. Rishita, can you see? Okay. मैं sentence को लिया गया ना Lama? Given below is how images are formed from a plane mirror. When you are drawing ray diagrams or anything that is relevant to light rays, if it is a straight line, please use a ruler. Okay, හැමලෙම ruler එකක් use කරන්න ඕනේ straight line එකක් නම්. Other instances it's okay, but when it comes to light, when it comes to ray diagrams, it is compulsory. Okay, so I'm gonna first draw a plane mirror. This is a plane mirror. And as I said previously, in a plane mirror, you have to shade one side to show that it is the back of the mirror. So this side is the back of the mirror. Like that. Okay. Now let's say I have an object, right? Now I'm not going to draw like a big object. Mama nikan chuti dot ekak tiyarnang. Let's say this is my object. So always in ray diagrams, object I denote with a capital O. Capital O කියන object එක. Now මෙන්න මෙහෙම light ray එකක් යනවා මේ object එකේ. A light ray like this goes from this object, strikes on the mirror and reflects. Now in a plane mirror, when you're sending a light ray with an angle, let's say this is the normal. At the point of incidence, you can draw a normal now. It will be reflected in such a way that angle of incidence is equal to angle of reflection. So it will be reflected like this. Like this. So here, if this is the angle of incidence, this is the angle of reflection, they should be equal, as we know. Maika danta metana pennanna naha, but whenever a light ray is being, excuse me, when a light ray is being sent with an angle, it will be reflected in such a way that the angle of incidence is equal to the angle of reflection. So this is one of the light rays. Then I'm to see how images are formed from the object. Object ki image ka komada hadanne kiyala bala. If I want to see how images are formed from a plane mirror, mama, I have to use at least 2 light rays. Now here I have shown how one light ray is reflected. I'm gonna show another light ray. Now मैं again thawa light ray ka kya. So where it hits the mirror, I will draw the normal. Okay, so this is the incident ray. And you know, when an angle is, when a light ray is sent with an angle, it will be reflected in such a way that the angle of incidence will be equal to angle of reflection. So it will be reflected like this. So Mitanath, if this is the angle of incidence, this is the angle of reflection, they should be equal. So Mammitanath is equal with it. So now I have 2 light rays. Both the light rays started from object O, struck on the plane mirror and was reflected. So you are standing at the front of the mirror. So where is the image formed? Usually in a plane mirror, when light rays reflect, at least දෙකක් ඕන කියවනේ මම. දෙකක්වත් ඕන අඩුම තරම්. දෙකට වඩා තිබ්බට කමක් නැහැ. The point where the reflected light rays meet is the point where the object is formed. Now look at this reflected incident light ray and reflected light ray. This is one reflected light ray. This is another reflected light ray. ඒගොල්ලෝ යන විදියට, are they ever meeting at the front of the mirror? Do they look like they're meeting? Will they meet anywhere? Or are they moving away and away from each other? What do you think? Yeah. Yes, Mayum, the others, what do you think? Are they meeting? Okay, Risinti, here what happens is this. Now, if you want to see how the image of an object is formed, you need to show the reflection of at least 2 light rays. Light rays dekakka to consider කරන්න ඕනේ. ඔන්න මම එක light ray එකක් යවනවා from the object like this. This light ray hits on the mirror and will get reflected. එයා reflect වෙද්දී අපි දන්නවා incident angle එකයි reflected angle එකයි equal කියලා. Then I told you we need at least 2 light rays now, so I'm drawing another light ray from the object. එයාත් මෙහෙම mirror එකේ වැදිලා, it will also be reflected in such a way that the angle of incidence and the angle of reflection are equal. Up to that point, is it clear, Cindy? Okay. Then what I said was that image එක හැමලෙම හැදෙන්නේ reflected light rays දෙන්න හම්බ වෙන තැන, meet වෙන තැන. මේ එක reflected light ray එකක්, this is the other reflected light ray. But ඔයා බැලුවම පේනව නේද මේ දෙන්න කොයි වෙල ඉස්සරහ හම්බ වෙන්නේ නේද මේ? They're kind of moving away and away from each other. Can you see that? එක දැක්කා කියලා කියන්න thumbs up. The reflected light rays are moving far and far apart from each other. Now what do we do? The reflected light rays must meet at some point, but they're not meeting at the front of the mirror. එහෙනම් අපිට එකම එක option එකයි තියෙන්නේ. We are going to mirror එක ඉස්සරහ හම්බෙන්නේ නැත්නම් අපි assume කරන එහෙනම් it will meet behind the mirror කියලා. මේ reflected light rays දෙන විතර ඉස්සරහ හම්බෙන්නේ නැහැ නේ, so I extend them backwards. මේ පිටිපස්සට extend කරනවා. Like this. So when this is this reflected light ray, I extended it backwards. But when you're extending it backwards, dotted dash lines direct straight line okay? So this is this reflected light ray. Hondara rule එකක් තියලා අඳින්න. then අනිත් reflected light එක මෙයානේ. එයාවත් මම පිටිපස්සට extend කරනවා. Like this. Like this. And we can see, okay, they didn't meet at the front of the mirror, but they are meeting at the back of the mirror. They're meeting here. This is where the image is. Don't worry about anything else. මම කියපු ටික විතරක් තේරුණාද up to that point, because I will further explain this, but up to that point, is it clear? Give me a thumbs up. Okay. එතකොට, okay, is the image formed behind the mirror? Actually, when you're standing in front of a mirror, that means image is formed behind the mirror. So behind the mirror is not a physical location. Can physical behind the mirror? It is just hypothetical. Right? Hypothetically, image behind the mirror. It's not like a real place. Since it's not a real place, image virtual image. It's not a real image. Like a real behind the mirror, what a mirror image reflection. You can see through the mirror, but you can't pinpoint. No, you can see. I mean, if you are standing in front of the mirror, you are the object, and image through the mirror, your reflection. That is the image. So you can see it, but you can't exactly pinpoint where exactly it is. So it's not a real image. Virtual image. We call it a virtual image. Is it clear? Mama, step by step. Is that clear? Okay. Then one more thing is that the distance between the mirror and the object, lamai, distance between the mirror and the object, we call it object distance. And the distance between the mirror and the image, we call it image distance. In a plane mirror, lamai, object distance and the image distance are considered to be equal. එකනේ මම mirror එක ළඟම හිටන් හිටියොත් මගේ reflection එකත් ඉන්නේ ළඟමයි. මම mirror එකේ ගොඩාක් ඈතට ගිහිලා mirror එක through බැලුවොත් මගේ reflection එකත් ඈත තමයි ඉන්නේ. So object එකයි mirror එකයි අතරේ තියෙන distance එකමයි mirror එකයි image එකයි අතරේ තියෙන්නේ. Again, as I said, the image is not a real image. It's virtual. It's not actually there. But hypothetically ගත්තාම ඔයා mirror එක ළඟට ගියොත් ඔයාගේ reflection එකත් ළඟට එනවා. ඔයා mirror එකෙන් ඈතට ගියොත් ඔයාගේ reflection එකත් ඈතට යනවා. Okay? So that means the object distance is equal to the image distance. Is that clear? Okay. All right. Time to draw this then. ළමයි මෙතන මේක point එකක් විදිහට ඔයගොල්ලෝ ලියුවානේ නේ? You wrote this as a point, no? So draw this diagram underneath, and I will write a point here. I have a question. Now, this is where the image is, no? මෙතනට light rays ඇත්තටම යනවද? Do light rays actually go inside the mirror? No. Because remember, mirror can opaque object එකක්. It's opaque. It's not transparent. If it was transparent, අපිට අපේ පේන්නේ නැහැනේ. It's opaque. So light rays will not actually go behind the mirror. Light rays are මෙහෙම. මෙහෙම ගියා මෙහෙම. Then මෙයාත් මෙහෙම ගියා මෙහෙම. Just because the reflected light rays are not moving, so not meeting at the front of the mirror, we just extend them backwards and see if they are meeting at the back of the mirror, and they are. එතන තමයි image එක කියලා කියන්නේ. Yes, Tinura, good point. අපි මේක ලියලා then I will come to that point. That's true. So what he's saying is that images වල side එක මාරු වෙලා නේද එන්නේ කියලා. That is true. So ඔයා mirror එක ඉස්සරහා හිටගෙන ඉන්නකොට ඔයා ඔයාගේ right hand එක උස්සනවානේ. ඒතර mirror එකේ උස්සන්නේ left hand එක. Reflection එක. I mean right left මාරු වෙලානේ තියෙන්නේ නේ. So that we call it laterally inverted. ඒකත් මම මෙහෙමම කියන්නම්. So when you're standing at the front of the mirror, if you are raising your right hand, the reflection of the mirror, like your reflection, is raising her or his left hand. Right left මාරු වෙනවා. ඔයාගේ left hand එක උස්සනවා නම් mirror reflection එකේ right hand එක තමයි උස්සන්නේ. So right left මාරු වෙලා we call it laterally inverted. Okay, let's try this. Okay, draw the diagram. Also, ළමයි මම දැම්මම ඔයගලන්ට කියන්නම්, when you are drawing a light ray, always remember arrowhead එක තියෙන්නම ඕනේ. That is a mistake that a lot of you make all the time. Not you, මොකද ඔයගලන් දැන්නේ පටන් ගන්නෙ. But ළමයි light ඉගෙනගෙන පස්සේ අපි questions කරද්දී, past papers එම කරද්දී හැම ලේකම වරද්දනවා. Light rays අඳිනකොට if you just draw a line, it's wrong. You don't get marks for that. You must draw the arrowhead. It's very, very important. So always keep that in mind. Huh? Okay, quickly write. quickly write. Draw කරද්දි හොඳට straight lines අඳින්න and angles එහෙම චුට්ටක් බලන්න. I told you right, angle of incidence should be equal to angle of reflection. එහෙම equal උනේ නැත්නම් ඔයාලට මේක මේ විදිහට එන්නේ නැහැ. Also one very important thing that I have to tell you is light lesson එකේදී නම් ළමයි I need to see your notes every day. So I would very much appreciate it if you can send your note in photos to me on WhatsApp right after the class. ඒක drag කරන්න එපා. හෙට වෙනකන් අනිද්දා වෙනකන් තියන්න එපා. ඒතර ගන්න අමතක වෙනවනේ. ඒකින්ද අදම class එක ඉවර කරා. I know you must be sleepy or tired or hungry or whatever, but you know it just takes 1 minute. Tatagala click කරා, like it doesn't have to be like super high quality cam scanner. එහෙම වෙන්න ඕනේ නැහැ. I just need to see that you have drawn the ray diagrams. මොකද physical class එක නම් ලේසි මට බලන්න, but online class එකේ මේ වගේ lessons ටිකක් challenging, right? Because the ray diagrams have to be perfectly accurate. ray diagrams ලස්සනට ගානට ඇඳලා තියෙන්න ඕනේ. ඒක මම අනිවාර්යයෙන්ම check කරන්න ඕනේ. මම හැබැයි හැම එක්කෙනාගේම වෙන වෙන පස්සෙන් එන්නේ නැහැ. මිහෙලිය එව්වද, අශ්විතා එව්වද, චෙනුලිය එව්වද, තිනුර එව්වද, මෙත්න එව්වද, එහෙම කියලා මම හැමෝගෙම පස්සෙන් එන්නේ නැහැ. But I told you it's very important. It's very important for me to check your ray diagrams. It's very important for you to get your ray diagrams checked. ඔයාලගේ note එක හරිද වයිද කියලා check කරගන්න එපා නේද? So ඒකින්ද ඒක මට අනිවාර්යෙන් එවන්න. ආයේ දෙතුන් සැරේ I can't beg you. Okay? So ඒකයි මම කියන්නේ. ඒ කියන්නේ ඔයගොල්ලන් එහෙම කියන්නේ නරක හිතකින් එවන්න නැතුව ඉන්නව නෙවෙයි. I know you forget, but since you know that you're forgetting, better send it today. අද මම 9:30 class එක ඉවර කරනවා. So ඒ වෙලෙම photo එක එවුවා. ඉවරයි. Because anyways we are not doing too much today, so whatever we are doing, send it to me. I'll check. මෙතන මේවා angle of incidence and reflection equal වෙන්න වගේ shape එකේ අඳින. You have a protractor, right? So otherwise මේක එන්නේ නැහැ ඒකයි. Make it faster. If when you're done, let me know in the chat box if you're done. Okay, some of you are done. So for others, I will give like 1 minute. Okay. Okay, Lama, I think that's enough time. Put a subtopic, not a subtopic, like a proper topic. Curved mirrors. Spherical mirrors. Curved mirrors / spherical mirrors. Quickly put a subtopic. Okay. Let's write a few points and then we'll do the discussion properly. මේ මම පස්සේ explain කරන්න, just write it. Quickly write these 2 points, 3 points. Okay. Okay. Now, since these now, if you take a plane mirror, I told you earlier, plane mirrors have a flat surface. But these curved mirrors, the reflecting surface, again, light reflect when a surface, it's curved, right? And also these curved mirrors, with the spellings, but I hope you wrote the right spellings. These curved mirrors, we can imagine them as if they are parts of a sphere. Ekin අපි ඒවට spherical mirrors කියලා කියනවා. We call them spherical mirrors. I will explain what that means. Now let's say we have a sphere. One second. ඔන්න මේ තියෙන sphere එක. මේ sphere එක, let's say this is a glass sphere, right? Let's just imagine in your head, this is a glass sphere. මේ glass sphere එකේ the center, I will label it as C. I will label it as C. C means center of curvature. Okay, අපස්සෙගලියමු. C means center of curvature. That is the center of this glass sphere. Okay. මේකේ මම මෙන්න මේ, I'm going to draw a diameter like this. I'm going to draw the diameter like that. Okay. And one side of this sphere, I'm going to shade like this. This is a, you know, normal mirrors are also made with glass, right? Samane mirrors are then glasses welling. Glass එක කරන් එක පැත්තක් full cover කරනවා. එතකොට අනිත් පැත්තෙන් වාට වගේ reflection එක පේනවා. That is how mirrors are formed. So this is also a glass sphere. What we are going to do is we are going to cover one side like this. එතකොට මේ පැත්ත තමයි back of the mirror, මේ පැත්ත තමයි front of the mirror. Up to that point, is it clear? An imaginary glass sphere, center is C, center of curvature. One side, I'm going to shade it in such a way that outside is shaded, inside is the mirror surface, like this. එතකොට මෙතන, if you look at this, මෙන්න මේ මැදින් මම draw කරපු line එකට මම කියනවා principal axis කියලා. I call this line principal axis. Okay. And the point where the principal axis meets the mirror, I label it as P. P means pole. Right. මෙන්න මෙහෙම mirror එකට අපි කියනවා concave mirror. This is called a concave mirror. Since a concave mirror can be imagined as a part of a sphere, we call it a spherical mirror. And also it has a curved reflecting surface, so we call it a curved mirror. So this is a curved mirror and also we call it a spherical mirror. Again, let me tell you, we are imagining a glass sphere, just imagining, it's hypothetical. Like ඇත්තටම හැමලේම concave mirror එකක් එක glass sphere එකක් නැහැ, we're just imagining. Glass sphere එකේ the center is C, we call it the center of curvature. Then one side of the glass sphere I have shaded in such a way that I have a curved mirror, right? It's curved inwards. අතුල් පැත්තට තමයි මෙයාව curve වෙලා තියෙන්නේ. This is the mirror surface now. It's curved inwards. So the midpoint of the mirror, I call it P, which is pole. And the line joining P and C, when the make up a principal axis. This is how a concave mirror is formed. Is this clear, Laman? Others? Okay. Then there's another. One second. Let me erase this unnecessary things. I have another sphere. Now, me පාර මම මොකද කරන්නේ? මේ sphere එකේ I choose one side and I'm gonna shade the inside of that side. මම අතුල් පැත්ත තමයි shade කරා. එතකොට මේ පැත්ත තමයි mirror surface එක. Now this surface is curved outwards, no? So this mirror surface is curved outwards. Why? Because I shaded the inside part and this is the mirror part and the mirror is curved outwards. So here also the midpoint of the mirror, I call it P. This is C, which is center of curvature. And this line, I call it the principal axis here also. Make a topic, convex mirror. Concave mirror, it's curved inwards. Convex mirror, it's curved outwards. Is that clear, Lamai? Okay. Metana, I'm going to mark another point, but I won't explain it now. I will explain it later. Pole ekkai center of curvature ekkai hariyatama midpoint එක, I'm going to mark it as F. I will tell you what F is later. The exact midpoint between P and C, I mark it as F. Here P is here, C is here. So this is F. I mark it as F. අපි මේ points ටික මොනවාද කියලා ලියාගමු. You can start drawing, Lamai.
Teacher, done.
Okay, others? Have you all finished? Thumbs up? Okay, great. Now we will be talking about each and every one of these mirrors separately. Before that, Mamitane F kila. So let's talk about what this F means, right? Put a subtopic, focal point. Focal point or focus. Focal point or focus. So this is what happens, right? Now, may I will a concave mirror kakne. So first of all, let me draw a concave mirror. Maybe a concave mirror. So this is pole P. And this is the, sorry, this is the principal axis. Hambalem imaginary sphere draw karandu now, okay? This is the principal axis and this is the center of curvature. Right? So we have P, we have center of curvature. And this is the concave mirror. So what I'm going to do is I'm going to send a parallel light ray to this mirror. A parallel light ray. My principal axis second parallelly, I'm going to send a light ray to the mirror. Like this. A light ray parallel to the principal axis. When I send it to the mirror, now in the mirror light is reflected now. It will be reflected and it will move along like this. Sorry, one second. It will be moving, it will be reflected like this. Reflect. Okay, like this. So when you send a parallel light ray to a concave mirror and it strikes on the mirror and it gets reflected, the point where it meets the principal axis, that means here, we call this the focal point or focus. Api thawa light ray ka kya parallel? Yatin yawanna man thawa light ray ka parallel to the principal axis. If I send a light ray like this parallel to the principal axis, this also will get reflected through the focal point. Any light ray that you send parallel to the principal axis, when it gets reflected, the point where it meets the principal axis, is what we call the focus or the focal point. Is that clear, Lamai? Is it clear? Okay. Now this is a concave mirror. Okay, this is a concave mirror. Can you draw this fast? Can you draw this? ඒ කියන්නේ concave mirror එකකට parallel light rays ආවම ඔක්කොම එහෙම එකතු වෙනවා නේ. එකතු වෙනවා. The point where they meet on the principal axis is what we call the focal point. Quickly draw this one. F is the focus or focal point. Quickly draw this, Samay. I will set a timer for 2 minutes. Then we'll also draw the convex mirror before we end the class today. Okay. Have you all finished, Samay? Who needs more time? No. Yes, Risindi, those are the only PDFs. In grade 10, අපිට හැම lesson එකකටම PDF මම දුන්නේ නැහැනේ. Only for certain lessons only I gave PDFs and ඒ ටික තමයි මම ඔයාලට එව්වේ. But මේ පාර grade 10 කට්ටියට ටිකක් වැඩිපුර PDF set වෙයි because I'm planning on doing more lessons as printed notes. ඒතර ඒ extra PDF ටික ඔයගලන්ට මම එවන්නම් හැමෝටම. So for an example, for the third lesson, which is structure of matter, there is going to be a PDF. Which you all didn't get. You hand wrote the note, right? ඒතර ඔයගලන්ට මම ඒකත් එවන්නම් in case you, I don't know, find it easier to use the printed note. Okay. Okay, so this is a concave mirror. What about a convex mirror? Now look at this one. Convex mirror එකක් curve වෙලා තියෙන මෙහෙමනේ. It's curved like this. Oh many. Bana convex mirror එකක this is the front of the mirror. This is the front of the mirror. And this is the back of the mirror. So center of curvature is behind the mirror. Right? Center of curvature is behind the mirror. So here, if this is the core, and if this is the principal axis, center of curvature is behind the mirror, like this. Not at the front of the mirror. That means a concave mirror is front of the mirror. But convex mirror is center of curvature is behind the mirror. Is that clear to you, Lamai? Thumbs up, please. Okay. I'm going to send a parallel light ray to this. I'm going to send a parallel light ray. A light ray that is parallel to the principal axis. Now we have a problem. That method is reflected this. But here, when it is reflected, will it go behind the mirror? Will it go behind the mirror? It won't go behind the mirror, right? It will not go behind the mirror. Mukada hamalema light rays mirror ekaka pitipasata yanne they always get reflected. Now this is what happens. When this light ray is reflected, it will be reflect. Now this mirror is curved outwards. Mirror එක outwards curve වෙලා තියෙන්නේ. මේ light ray එක මෙහෙම දෙවිය reflect වෙන්නේ ඉන්දික පැත්තට තමයි reflect වෙන්නේ. Because it's curved outwards. So this light ray will be reflected like this. When we reflect outwards. So now this here reflected light ray, it meets the principal axis. The point where it met the principal axis only, I labeled it as focal point. But here, this reflected light ray is not meeting the principal axis. It's just moving away. So, since it's not meeting the principal axis, I'm going to extend it backwards. One second, Lamai. Let me quickly change this a bit. Since it is not moving on the principal axis, what I'm going to do is I'm going to extend this light ray backwards like this. When I extend it backwards here or now, this light ray is meeting the principal axis, but it's not the real light ray. I just extended it backwards. So the point where it met the principal axis, I call it the focal point. So it's not the real light ray meet venna hai, but I extended it backwards. Let's send another parallel light ray and see what happens. Parallel light ray ka kya naam hai? This light ray will also be reflected like this. So since it's not meeting on the principal axis, I'm going to extend that backwards. This is the light ray. It's reflected outwards. Since it's reflected outwards, it will not meet the principal axis. So since it will not meet the principal axis, I'm going to extend it backwards, and I can see again that meets on the principal axis at the focal point. Is that clear to you, Lamai? Concave mirror ka gana kelimma reflect inward. So the point where it meets is the focal point. Convex.
Yes, teacher.
Yes. It's
Clear.
reflected outwards. Yes. So since it's not moving on the principal axis, I extend it backwards. Again, F is focus or focal point. Quickly write this as well. Then there are 2 more points to write before we end. But first draw this one. Onna mega concave mirror, mega convex mirror kya liya gatat kamak nahi. Quickly write.
Teacher, after this, do we have any coins?
Yes, we have 2 more points, but first draw this one, then I will give you the points.
Done, teacher.
Okay, let's wait until others finish. So I will write the 2 points as well. Quickly write this, Lamai. So here the last point means, as I said previously, pole and center of curvature harita method තමයි focal point it. That means this distance, wait. That means this distance and this distance are equal. Here also this distance and this distance are equal. Also, one last point that I have to add here, the distance between quickly, right? I will set a timer for 2 minutes.
Teacher, none.
Others 30 seconds left. So next week, Tamapita, we have the most difficult job, which is drawing ray diagrams. As I said, I think, not I think, it is a lesson for 3 weeks. So I think we'll have to drag the lesson for 2 more weeks, right? Have you all finished, Rama? Give me a thumbs up if you have finished. Okay. So next week we will be meeting in the new month in March, 7th of March. If you have any questions, you can ask even on WhatsApp. I will send the whiteboard note as well. Okay, then see you next week, Lamai. Good night.
Teacher, I sent you the notes also.
Okay.
Thank you, teacher. Thank you, teacher. God bless you, teacher. Have a nice
Good
day.
night.